Okay, we are going to do translations in this video, and this is just another transformation. Again, our transformations that we're focusing on first are going to be rotations, reflections, and translations. A translation is just a transformation that is basically the smallest definition that I can give would be a slide. But this definition would be a transformation that moves all points of the original figure the same distance and in the same direction. So for example, point B right here and point Y, those 2 points are the same position on that triangle. All that's happening here is I'm basically creating a straight line from that point to that point, from this one to this one, and from this one to this one. And those lines are not only parallel, but they're the exact same length. I don't know if I can move them. I'm going to try. Nope, I can't. I thought maybe I could move the lines around. But if I were able to move them, they should, in theory, be able to stack right on top of each other perfectly because they're the same length and they're in the same direction. So now we're just going to get into some ALEKS problems, what they would look like. For example, I'm trying to figure out if this shape could translate onto that other shape. Basically, if this was like a puzzle piece and I was trying to put it in the puzzle right there, would it fit? I'm just sliding it. I'm not rotating it. I'm not flipping it or anything. And the answer to this is yes, it would. It would slide right in there. This point would line up with this one. This one would line up with this one. This one would line up with this one. This one would line up with this one. And it would slide perfectly right in there, or translate, as we like to call it. This one, on the other hand, you couldn't just slide this one right in there. You could, if you ended up flipping it or reflecting it first, it would look something like that. See if I can draw this out here. See, that would be a reflection, and then I could translate it straight down, but not without reflecting it first. So this one would be a not possible. Okay. It said it wanted a rule for each of them. So I guess we should talk about rules really quickly. And something that maybe I should have mentioned in my previous video, but I'll just mention it here. When we're writing rules, I have to mention this. We're always going to write it with x comma y as the first part, and then our arrow is always going to be, I just call it changes into, or it changes to be something else. So on this one, if we just looked at one of the points in particular, for example, this point right here on the very tip, if I'm drawing a rule for this, I've got to figure out where it's moving and where it starts from, because that's always the biggest thing. Like, where is it starting and where is it finishing? I will highlight or color in maybe this one. This is the one where I would be starting from, and I can just figure that out from the directions. It says translate the solid figure into the dashed figure, so we're starting with the solid one. Now, what's happening here? Well, I am moving over that much, and then I'm moving down that much. So I got to count these up here really quick. So this looks like 1, 2, 3, 4, 5, 6, 7, 8 on the top. I hope I counted that right. But then down here it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 going down. So I would say it's going 8 to the left and then 10 down. Well, since we're talking left and right, that's our x-axis. And that would be in the negative direction that we're going. We're going left, so that's negative. And then we're also going down, and in the y's, that's also negative. So my rule for this one is going to end up being something like this. My x is changing from just the regular x. It's actually going to the left 8. So I can note that it's going to the left 8 by putting a minus 8. My y is going down 10, and I can denote that it's going down by putting a y minus 10. That's all the rule is. You're just figuring out where it starts and where it finishes, If it was going the other way, like this way, then it might be a positive 8, and if it was going up, it might be a positive 10, but since we're going left and down, those are negative. Okay, next one. Draw the following quadrilateral after a translation, 3 units to the left and 3 units down. So now we're translating it. It says it wants it 3 left and 3 down. So every single one of these points, for example, this one right here, I'm going to go 3 left, 1, 2, 3, and 3 down, 1, 2, 3. That's where it's going to be. And now you probably shouldn't have these extra dots on your picture, so I'll erase them. But I'm going to do that with all of them. So there you go. That's one of them. And then it also wants a rule for this one. So let's just do the rule right away. Again, we always start with x comma y. You never put a negative x or a negative y, even though like this point right here, it's in the negatives for the x and the y value. But we're not going to put an x and a y in there. Or I'm sorry, a negative in our x and our y's. To start. To finish this here, again, we moved it 3 left. That's in the x direction, and that's in the negative direction, so it'll be x minus 3. And then we did 3 units down. Well, for the y value, that's also in the negative direction, so it's y minus 3. Next one, it says 3 units to the right and 1 up. 1, 2, 3, 1, right there. 1, 2, 3, 1. 1, 2, 3, 1. Okay, and then if I'm going, I gotta draw my x comma y first. If I'm going 3 units to the right, that would be in the positive direction for x. And then if I'm going 1 unit up, that's also in the positive direction for y. So that's where you would be. Continuing this here. These are pretty much the same, so I'm just going to go pretty quick. Let's just call out where these points are. So r prime was at 0, 2, it looks like. S prime is at negative 3, 3. And T prime is at negative 4, 6. Okay? I just filled in basically these things here. I just had to write them off to the side. But I'm just showing where those points are going to be. And then it wants a rule. I really only need to look at one point to find the rule. And remember, I've got to look at my t and go to t prime. I can't start at t prime and then go to t. So I'm going to go 1, 2, 3, 4, 5. Looks like it's 5. 1, 2, 3, 4, 5, 6, 7. Okay, so it went in the negative direction 5, and then it went in the positive direction 7, upward. So it should be, where are we at here? Negative 5, positive 7. Scrolling down now. Okay, so for this one, r looks like it is, or sorry, r prime is going to be at positive 5, 0. S prime looks like it's at 2, 4. T prime looks like it's 6, 5. Okay. And then where are we going with these? I'm just going to use point T. It looks like I'm going 1, 2, 3, 4, 5, 6, 7 to the right, and then up 1, 2, 3, 4, 5, 6. So 7 to the right, up 6. Looks like it's that guy right there.